Okay, back to computing the slope of lines, but now we're taking it a step further. In the last example, we computed the slope of a particular secant line to this graph to estimate the slope at this point. Now we're going to find the actual slope of that tangent line. Now remember, this tangent line, which I've drawn with a dotted line here, is the line that matches the steepness of the graph and touches it at this one particular point we're interested in. The steepness of that tangent line is what we define to be the steepness of the graph. So this is really what we're shooting for. Okay. So the formula which gives us the slope of the tangent line is actually the same formula as the secant line with one difference. Instead of picking a particular value of delta x, we leave delta x as a symbol. And we look at what happens to the slope of the secant line as delta x gets closer and closer to 0. Okay. So actually the only thing we know is that in this formula that we're interested in is that we're definitely interested when x is equal to 1. What's the slope going to be? Okay. Well, the slope of the graph, in other words, the slope of the tangent line, is f of 1 plus delta x minus f of 1 all over delta x. Okay. Now, since we have a function here, I can substitute these things into the function and simplify. This will give me the limit as delta x approaches 0. Okay. Well, when I put 1 plus delta x into this function, I get 1 plus delta x squared plus 1, okay, minus f of 1. Well, if I put 1 in for x, I get 1 squared plus 1, which is 2. Okay. So that's all over delta x. Okay. So this is f of 1 plus delta x. This is f of 1. I'm subtracting those. Okay. Well, again, because of space, I'm going to have to kind of abbreviate this, but what we do next is just simplify. If we FOIL this out, we get 1 plus 2 delta x plus delta x squared, okay, plus 1 minus 2 all over delta x. Now, you can simplify this. 1 plus 1 is 2, minus 2 is 0, so those all cancel. And if you look at the limit, which I'm going to have to go back and erase some of my earlier stuff to get the board space here, what I get for the slope of this tangent line, the limit is delta x approaches 0 of 2 delta x plus delta x squared over delta x. Now, the numerator, each term has a factor of delta x, so I can cancel the 1 in the denominator with 1 in the numerator from each factor. And what I end up with is this. The limit as delta x approaches 0 of 2 plus delta x. Okay, now, right here, I've gotten rid of the delta x in the denominator, so finally it's okay just to put 0 in for delta x. I can use direct substitution now. And of course, so I replace that with 0, I get 2. So the slope of this tangent line, the tangent line on the graph of x squared plus 1, at this point, 1 comma 2, the slope of that tangent line is 2. So we say that the graph itself has a slope of 2 at this point. Okay. At a different point, the slope of the tangent line would be different, but the calculation would be very similar.